Hi, my name is Nicole Williamson, and in this video, I will be describing the free body diagram of a train at rest and a train in motion. This is for University Physics 1. This is a clip of a train at rest that you can see from my backyard. This is a clip of a train in motion that was right down my road. And this is my explanation for the free body diagram of a train at rest and a train in motion. At the beginning of this video, you saw a clip of a train that was at rest. This is the train and this is the track it's on. Since it is at rest, it just has the forces, the weight force, which is acting down, and that is mass times gravity, and the normal force, which is opposite of the weight force, that is equal to it. So for this train, we have the normal force that equals the mass times the gravity, and our total net force is going to be 0 because the object is at rest. If we were to put this on a graph for the free body diagram, we would have the normal force working up and the weight force working down. And this is for the train at rest. In the next clip, you saw a train in motion. Here we have our train. Here's the track again, and the train was moving this direction, and then it had a force from the engine pushing it in that direction. So we have a force pushing it this way from the engine, and just like the forces that were on the train at rest, we still have those forces in the train in motion. So we have our weight force acting down, which is mass times gravity, and we have our normal force working up. And those are still equal to each other because every force has an equal and opposite force. So for this, and also since it's working the engine force and it's on a track, we have a friction force that's moving the opposite direction. And for our friction force, it's going to be equal to a coefficient of friction times the normal force. And this coefficient of friction depends on if the object is in motion or not. So since our train is in motion, it's going to be the kinetic friction coefficient. And the net force of this entire train is going to be equal to the force of the engine minus the friction force, since it's working against the engine, and it's also going to be minus the weight force because the weight is just working against the engine, it's not helping it. If we were to put this on a graph for the free body diagram, we would have the normal force moving up, we would have the weight force down, that's equal to the normal force, we would have the engine force that's going this way, and we would have the friction force that's going the other way. And that is my explanation of a free body diagram of a moving train and a train that was not in motion. Thank you.